Alright guys, so I thought I might make a quick video reviewing some of the things we talked about with regards to transformations of logistics functions, and also to talk about another way we can see that horizontal shift that we get from the coefficient to the exponential in the denominator of the logistics function. So what we'll start by doing is just sort of going through the basic parameters of our regular logistics function, right? So right here with our regular logistics function, we said we had a top horizontal asymptote of y equals 1 and a bottom horizontal asymptote of y equals 0. And we said that with the regular logistics function, we cross the y-axis halfway between these two asymptotes. And in this case, that would be at 0.5, right? So with the transformation that we're seeing right here, we first looked at the 8 in the numerator. We said that we could see that as a multiplication of 8 outside of the function, which gave us a vertical stretch of 8. And it shifted our top horizontal asymptote from 1 all the way up to 8. So looking at our regular logistics function, we're going between the horizontal asymptote of 1 and the horizontal asymptote of 0. And we're looking something like this. Actually crossing more halfway between those two asymptotes. But right here, with that multiplication of 8, we're seeing a vertical stretch, which means that we are going to see the top horizontal asymptote all the way up here at 8 now. And we're going to be going from that bottom horizontal asymptote to that top horizontal asymptote, giving us the graph that would look something like this. Right? Now this is basically just with that transformation of 8. The next thing we said we saw was the multiplication of 0.5 directly to x, giving us a horizontal stretch by the reciprocal, and the reciprocal of 0.5 would be 2. Right? So right here we can sort of graph that. We're going to see a little bit of a horizontal stretch here. Looks something like that for our logistics function with the transformation. Get rid of the old logistics function. It's just the vertical stretch of 8. And now we're looking at the graph looking something like this. Now right here, I want to talk about another way we can see the horizontal shift that the multiplication of 2 gives us in the denominator. Now right here, in general, we're going to say that if we were just looking at the two transformations we've talked about so far, we would see our logistics function crossing halfway between our two horizontal asymptotes still at 4, right? But one way we can see this shift that we are going to get by 2 is by noting where we cross the y-axis. If we're seeing a shift to the right, then our logistics function is going to cross the y-axis before the halfway point of 4. If we're seeing a shift to the left, then we're going to cross after that halfway point of 4. So right here, if we go ahead and take our logistics function and solve for that y-intercept, we can do that by plugging in an x value of 0. So we know x equals 0 on the y-intercept, which gives us f of 0 as 8 over, and then right here 1 plus 2, and then right here we're going to get e to the negative 0.5 times 0, which we could say is just e to the 0. This gives us 8 over 3 as the y-intercept, and in general we could say that that 8 over 3 would be basically 2.6 repeating. So right here what we're seeing is our logistics function, instead of crossing halfway, crossing before the halfway point at approximately 2.6, right? And we can note that y-intercept as basically a horizontal shift. So instead of writing out the horizontal shift that we would get, which would be a little more complicated, we can basically go through and say that we've got a new y-intercept of 0 and then 2.6 repeating. And since we know 2.6 repeating is going to be before the halfway point, we can note that that would be a horizontal shift to the right. So right here, what I want you guys to do is to pause the video and give this one a shot, G, and we will come back and look at this one in a second. In general, what I want you guys to do, it says in the directions that I'm just looking for the asymptote and the y-intercept, but I also want you to describe that horizontal stretch or horizontal stretch or shrink that we're going to see from any multiplication inside the exponent. So I want you guys to note all of those transformations, right? And then give a sketch of the graph. All right, guys, so we will pause the video and we will come back and look at this in a second. All right, guys, so looking at this one, we can first see from that 6 in the numerator that we're going to have a vertical stretch of 6, which gives us our top horizontal asymptote at y equals 6. We could say we have the bottom horizontal asymptote at 0 still, right? We have a horizontal stretch by a factor of 4 from that multiplication of 0.25 in the exponent, right? That would be a horizontal stretch by the reciprocal. And right here we can say we've got a y-intercept of 2. And again, we get that by plugging in the x value of 0. G of 0 is going to be 6 over 1 plus 2 times e to the negative 2.5 times 0, or e to the 0. And right here, that gives us 6 over 3, or 2. Right? So right here, we would see a graph that looks something like this. That would be the basic graph of our logistics function. So right here, we're going to stop the video and let you guys go ahead and give the rest of the homework a shot. All right. See you guys on Saturday.